And one was the fact that there are two connected issues. One is water availability, and one is water quality. And we ended up focusing more on water availability, and in part because of the sense that I think that's sort of the first line of need in some sense. And to the extent that water is more available, it can become more feasible to deal with quality issues as well. We noted complementary roles for systems level approaches and micro level approaches that both could be effective and complementary. One point was that a lot of the solutions that we thought about on water had a technology component, but also a strong policy and institutional component. And then also that exact solutions were very specific to context in water. One idea that we came up with from various dimensions, which seemed very interesting, was the idea of creating water information systems. And that you could really approach this from different levels of kind of specificity. And, you know, on the macro scale, this could relate to remote sensing and things that India is doing already that could help with water information, but you know, really focus that on pulling some of the information together. And then data on the micro scale, where it would feed back to individuals and households about their own usage patterns and also on local availability of water, quality of water, situations about the groundwater. And so our feeling was that this could really, if you put all these things together, it could really be very powerful and might enable you to then, as a government at different levels, to think about, well, what policy interventions might change behavior in ways that are useful. A technology connection here is that this would really be enabled by low-cost sensors and perhaps also software platforms, maybe even mobile phone applications that could be the interfaces for people to these water information systems. And part of that interface is how it interacts with people, and that could be a very important part. And Vinay brought up the possible analogy to efforts that India has made in food distribution and enhancing information around that, and that's an area where something like this has been quite successful. So another theme of our conversations was the very significant overlap between energy systems and water systems. And people gave various sobering examples of how not paying close enough attention to this overlap could lead to very serious consequences. And one example of that is if all your pumping is done with electricity off the grid, then you're extremely vulnerable if you lose your electricity. And indeed, this has happened in India and been very serious. So our recommendations in this area, you know, one was that policymakers really need to treat both of these issues together and are thereby likely to come up with much more effective solutions for both. There's also, again here, a micro component, which is designing ways that people, you know, kind of tools for people at the local level to have products that would integrate water use and energy use in efficient and effective ways. We talked a fair bit about water policies and some good examples from other jurisdictions about things that have worked. One was the idea of pricing water, and how you price water is very important to create the incentives for efficient usage. Education and creation of social norms around water use and on valuing water appropriately can be very effective. And then one idea that was interesting, and this was an example that was brought up by our colleague from Singapore, but also then we thought of some other examples of this approach, is that sometimes rather than using policy and regulation in a very prescriptive way, the government can essentially create like a request for a proposal to solve some water-related problem that the government prioritizes. And so this could be requests for proposals for technology innovation and development, but it could also be for policy innovation and business model innovation. And so, we thought there's a lot of merit to this approach as opposed to just telling people, well, you need to do this and this and let people innovate and then compare different pilots of these innovations to see which are more effective. And another issue that was brought up as being an issue in India, but I certainly think that this could go the same in the US or other countries, is the importance of evaluation to make sure that policies are achieving their intended results. Then another point that we came up with was about the idea of enabling platforms. And one part of this is enabling platforms for the technology development process and product development and then product diffusion. So that one stage is that, how do you make sure that people are turning technologies into real products that are useful to people? And a second aspect is once you have products, how do you enhance the diffusion rate of these products? One observation that a number of people made was that in water, there are demonstrations in jurisdictions and villages of practices that work. But often you'll have an adjoining village, for example, that will not be applying the same practices that are effective somewhere else or the same technologies. And so that this needs some further attention to, how can diffusion processes be enhanced. And then some other platform-like ideas. One was the importance of financial inclusion in addressing some water issues. And so we thought about the idea of some kind of M-Pesa-like system, like the money transfer by mobile phones, that might connect into water issues as well. And one thing that has been done that there's a group at Stanford that's worked on in collaboration with other groups is on mobile phone apps for water availability and for creating market information about where there's water available and what the quality level is of different kinds of water. And so I think this connects in again to this idea of water information being so important, and that this is a way that technology could really help. So finally, just a few specific technologies that we thought seemed to be very high priority. Rainwater capture was one important one, but also technologies through the whole water cascade, from the applications that have very high requirements like drinking water, all the way to applications like irrigation that don't have those same requirements. And so how you can capture the water efficiently, the wastewater from each step of this cascade, so that your overall use is very efficient. Sustainable groundwater pumping and recharging is very important. Other kinds of low-flow pumps is a niche that hasn't been explored very much, but there might be low-flow, low-cost pumps that could be very useful for micro-level applications. Efficient distribution methods. As I already mentioned, low-cost sensors could be extremely useful. And finally, another possible connection to an area that could help the water situation is localized fuel production technology or other ways of locally generating energy that both new ways of doing it and also ways of diversifying the energy that you might need to pump water and use water in other ways. So I'd like to, we had a great group, which I'd like to thank, and certainly Arjun or the group can chime in as well. Thank you.
Okay. Questions?
Actually, the friend from Singapore should say this, but Singapore has a total recycle system where all water gets recycled. I think so San Diego, I'm told. So I think Mumbai could use something like this, or even smaller towns.
Our colleague from Singapore, we discussed that Singapore model, the new water concept, but we kind of consciously did not put the word Singapore model because we wanted to make it more India-centric. But yes, there are opportunities to leverage the model from Singapore because the way they have made themselves water independent from Malaysia, it's really something. They recycle the entire sewage back to the system. So those are opportunities, yes. but it has to be kind of retrofitted to the concepts within India.
Yes.
Just a piece of information. Department of Science and Technology has already requests for proposals on water. Actually, they identified problems in different areas. It's called War on Water. If you go to DST site, you can see those requests for proposals.
I think the gentleman had a question.
Since this workshop is on decentralized systems, if all the dew condensation from air conditioning in Bombay is collected, I think it will take care of all the water problems.
Good suggestion.
Good one. If you even somebody was suggesting if you could just collect 1% of the rainfall that happens in India, we don't need water for the next 2 years. We don't need another monsoon. That's a good one.
Interesting. And then here.
The suggestion is basically regarding, see, once whether you're in Bombay or Delhi, you find a lot of people who migrate from villages and other parts of the people to these cities. One of the primary problems even they face, and perhaps even we urban Indians face while traveling out of Mumbai, is water. Many of these Bisleri bottles sold outside Mumbai, perhaps in Mumbai itself, are largely fake. So if you have a typical child or somebody within the family, you're hard pressed to treat that water at some location. Is there any way in which some chemical is there, in which I put some tablets into some source of water, and I can get some potable water immediately? Has Stanford worked on this, or do they have already an existing solution? Some low-cost chlorine or something like that? Does it exist?
I'm not aware of work along those lines at Stanford, but it's possible. Yeah.
Because I realize that the US military often has some kind of device, because they travel in a lot of remote locations and they have to get potable water quickly.
There is a South American solution for this, which won an international award, which is a straw-based solution where you can put it into a swamp water and pull it out, and it gives clean water, and it's $1 a pipe or something like that. So it's something very ultra cheap available.
I think there are two parts to it. One which you mentioned, chlorine itself is so low cost, you really cannot beat it. But the fact of the matter is that as long as you're talking about surface water, that is a river water, lake water, or pond water, it's probably not too difficult to treat it. The issue comes in India because we are using water from our groundwater. You have dissolved salts, you have arsenic, you have fluoride, you have nitrates, you have chromium. There is no magic pill that I know of that can actually attract all those things into itself and purify the water. I think the challenge is really in coming up with very cost-effective mechanisms that is mostly zero energy, because we do not have really predictable electricity in India to desalinate that kind of water, that kind of brackish water, which is arsenic, lead, chromium, and all those other impurities, and make it amenable for drinking or cooking. That's the bigger issue.
And actually, one quick addition along those lines. I mean, one thing that there was a group that worked on at Stanford was understanding in the subsurface where the arsenic contamination was coming from. And I think this was in Bangladesh, as I recall. And it was, actually turned out to be quite a useful project for figuring out how to site wells. And the other thing that I would mention where there is some work on Stanford is on adoption of household water treatments. Steve Luby is a professor there who's done quite a lot. And I think it points up, household water treatments is a great example of an area where it's not just a technology problem, because there are absolutely effective technologies for doing this, but like improved cook stoves or other kinds of things, it's not had very strong adoption.
Yes. In the coastal area, we are facing the water problem, energy problem. We can go for a renewable energy based desalination plant so that we can get the energy and water.
I think it's beginning to happen, but then most of the problems that we see within India are far away from the coast, where they are drawing water from the aquifers underground. That's where the bigger issue is.
Okay, one more question here.
This kind of system is based on reverse osmosis, hand carried, and you basically use a pump to pressurize the water and pass through the reverse osmosis module, and you get potable water from any water, and you are eliminating all of the minerals more or less and so forth. So that kind of system is available in the US. It's primarily used by people going on camping or going to Africa and so on. So it costs about $25 to $40, and you can carry it in your backpack basically, and you don't need any power because you are using your hand to pump the water through.
I think in general, though I should not say it, I work for GE, in general reverse osmosis is not a great solution for water treatment if you're taking it for drinking, because the recoveries are very low. We have yet to find some technology that can really have 90% recovery of water, because if you look at any domestic desalination reverse osmosis filter, 2/3 of the water really go down the drain, and that's a lot of wastage if you integrate the amount of water that could be wasted.
The rest of the water you can use it for other things. And this is when this is you are making potable water out of any water available.
Yeah, but if you have arsenic in your water, it's going to go to agricultural field, which is anyway going to come back to your stomach. So there has to be.
All right. We're running a little behind schedule, so I'll bring this to a close. But applause for all the groups. You all did a great job.